All right, here we go again. Let's see what happens. So, let's take an easy equation, or a relatively simple one to start out here. Okay, so we're going to solve for x, and we're going to solve for specific x values here. 0 less than or equal to x less than 2 pi. Okay, so we're going to limit our solutions, because truly, right, we could have an infinite number of solutions. All right. All right. So, how should we maybe go about solving this equation? What should we do?
Get sin x by itself.
Get sin x by itself. Exactly right. Yeah, we want to isolate the trig function. I put a 1 there, but really we're not going to have that many steps. Okay, so isolate the trig function. So in that case, we will, what? Subtract 1 and then divide the 2. That's right. So we get 2 sine x equals -1, and so sine x equals -1/2. Okay? And so now it's up to us to figure out, well, when, right? When does sine of x, or for what x values, when you take the sine of them, do you get -1/2? And again, you can refer to these reference triangles I drew up on the board there if you want to help you. All right? What are our solutions going to be here, though?
5 pi 6, 1 pi 6.
So, 5 pi 6, 7 pi 6. Nope. Mm-hmm. And then 11 pi 6, yes. Okay, exactly right. Right? And again, those are the only ones between 0 and 2 pi. So we're just going to keep it that way. Okay. This is different, or it's not exactly the same as when we were evaluating arc sine of -1/2. Right? Arc sine of -1/2, that is -pi/6. Okay? But here we're trying to find all the values between 0 and 2 pi that make this equation true, and so that's going to be 7pi/6 and 11pi/6. Okay? So, questions on any of that? Pretty straightforward. Okay. So then let's jump to a different one here then. Okay. So here, I'll have you guys try one. So you guys try here. So try sine of x plus the square root of 2 equals negative sine of x. Okay, and again, solve for 0 less than or equal to x less than 2 pi.
So when it's negative sine of x, does that mean there's a negative 1 in front of the sine?
There's a -1 in front of it. You can think of it that way. Yep. So go ahead and solve there. Okay, now I did make this one a little bit different because you have 2 trig functions, but you can work around that if you like. Oh, what's that?
We are. I'm in
Exactly.
For the untitled, aren't besides 1, 1 and square root of
Yeah, it's the same. It would be like it would still give the same ratios because that is similar to the one you just mentioned. So the
I have
ratios
a
would be
question. What's the importance of arc sine and like arc cosine? Like, why is it important to this?
Well, because of the nature of what they do, right? It's important to understand inverses because they help to cancel out the original functions and stuff like that. So it's like a bouncy kind of thing, I guess, you know, for solutions and
I was
things.
thinking like this is kind of like the same thing but different, but this gives more range.
Right. So the inverse functions are defined in a specific way, so they will be functions, as in you only have one y value for each x value kind of thing. This, we're trying to solve an equation, we're trying to come up with all the solutions that work, and so we're not worried about being a function or not. We're just trying to find all of our answers. It's like, and I think I've said this before, but I'll say it again. It's like the difference of taking
You're gonna do the
square root of 4. Right. It's the difference. It's like that kind of difference. Where when you have x squared equals 4 plus and minus 2, when you see just square root of 4, it's just 2. Because the square root of x is defined as a function. Okay, so what should we do here first step?
addition.
Add what to both sides? Sine x. Yeah, we want to get those trig functions together there. So we get 2 sine x plus the square root of 2 equals 0. Okay? And then what should we do to both sides? Subtract root 2. Okay? And then divide by 2. You got it. Okay? Exactly right. All right, now we have to figure out when does sine of x equal negative root 2 over 2. So yes, Alyssa?
Is it 5 pi over 4 and 7 pi?
Yes, it is. It is 5 pi over 4 and 7 pi over 4. Okay, questions on any of those? Those are answers. All right, let's keep rolling here then. That's pretty straightforward. Good job there if you got those all right. And most of you did as I was walking around, I saw, so that's good. All right. Okay, let's try this one we'll do together here. Solve for, and here I'm going to use theta as a variable. So solve for 0 less than or equal to theta less than 2 pi. Okay, so we want all the solutions between 0 and 2 pi.
Is that sine to the second power?
Sine to the second power, exactly right.
Some sort of rule like that just gives an answer.
You could just give an answer to this?
Yeah, can't you?
Maybe.
I remember getting a sheet of paper with all those things.
We'll talk about those later. Those are trig identities. Yes. So yeah, you could potentially like rewrite that using those, but not necessary for this one.
Yeah, it just doesn't look possible.
It's impossible. Give up, walk out, right?
Undefined is my answer.
Undefined.
But you can like define.
IDK, okay. Well, so any ideas about how we can proceed from here?
No, wait, hold on. We solve it first. Stop.
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 Cosine.
Subtract cosine from, you mean subtract 2 cosine from both sides?
I just subtracted 1. We got sine squared.
Well, if we subtract a cosine from both sides, because this is the term here is cosine theta sine, times sine squared, so we couldn't subtract that way. But we could, I mean, what else could we do though potentially?
Subtract 2 cosine.
Okay, so we could subtract 2 cosine theta.
Or you can just give up cosine. Divide by cosine.
So right, we can also divide by cosine theta here. So
Oh wait, you could just divide the cosine.
right, if you're trying to get rid of it there, right. So let's do that first. We'll divide both sides by cosine theta.
You don't get like. You just get root 2.
Okay, so then those cancel, and we're left with then sine squared of theta equals 2. Okay, and then sine squared of theta equals 2. What should we do from this point? Square root both sides, right? And so if I square root here, now because I'm in an equation setting, plus or minus the square root of 2, right? And so I get sine theta equals positive root 2, sine theta equals negative root 2. Okay, perfect. So now all we have to do is figure out when does sine of theta equal root 2 and when does sine of theta equal negative root 2. So, when does that happen?
That doesn't happen on the circle.
Okay, so it doesn't have on the circle, but does what's that? On the unit circle, right? It doesn't have. Yeah. Okay, so when does sine of theta equal root 2?
Never.
The answer is never. That's right.
So undefined was the right answer.
So undefined. Well, I don't know if I want to say undefined wouldn't be the right necessary answer there. It's just no solution, I would say here. These are not undefined. It's pretty close, yeah.
So when it looks dumb like that, you're telling us.
Right. So let's go back up a step here, Andrew. What was the issue here?
It's over. The sine, cosine, can't be above 1.
Right, yeah, sine's range, right? The highest value sine can take is 1, okay? Sine with no, like, amplitude, change. And, of course, this is just plain old sine of theta here. And so sine of theta cannot be greater than 1. Root 2 is greater than 1, okay? Mr. Wade, how are we supposed to know that root 2 is going to be some decimal? How are you supposed to know that's greater than 1?
Times 1 gives you 1, so obviously.
Well, the square root of 1 is 1. The square root of 4 is 2. So the square root of 2, which is between square root of 1 and square root of 4, has to be between what? 1 and 2, right? So it's somewhere in here, but it's got to be greater than 1, but less than 2, okay? That idea you just utilized right there is something called the intermediate value theorem, okay? That's the basic understanding of what we just talked about right there in so many words, I didn't really do it very officially, but that's a concept we'll be using in calculus should you proceed to calculus, next year and stuff like that, or later on in your math career. Anyway, no solution. So remember also, you can always check these answers with your calculator if you didn't know that. So for example here, whenever we want to check, anytime you have an equation that you need to solve and your calculator is available, you can graph the left-hand side, you can graph the right-hand side, and look for points of intersection. Since our solution here was no solution, how many points of intersection do we expect? None. 0. Okay, so I'm just going to show you here that we get 0 points of intersection. So cosine x sine of x squared. So I'm going to graph the left-hand side and y1. And I'll graph the right-hand side and y2. Make sure that your mode is set to radians since we're trying to find, radian calculations here. And then I'll also limit my x values to go from 0 to 2 pi. So I've got my y's, typed in there. Cosine theta, sine squared theta. Oops, did I do the sign? Hang on a second, I got a parentheses around this. That'll make it right. Let me do it this way. Sine of theta, quantity squared. Okay, so I square the sine. So it's cosine times sine squared, and then 2 cosine theta, that's right there. Okay, and I'm going to adjust my window because I only want to really consider x values between 0 and 2 pi. Okay, and I'll graph it. So there's the first curve. Kind of interesting. Okay, and then
There are solutions.
wait a minute, there are solutions.
At something.
Something.
When you then thought there was no solution.
So, something happened here. Okay?
You gotta subtract the 2.
We gotta subtract the 2 cosine over. Yeah. We don't want to divide. We want to subtract the 2 cosine
Did that.
over. What?
You purposely did that way.
I don't know what you're talking about,
You just screwed up.
Cameron. I would never.
He likes watching us fail.
No, it's just so that when I make real mistakes, you'll think I'm just screwing with you in the future. And like, oh, that way I'll be like, yeah, I meant to do that one. Aha, you learned a lesson, didn't you?
But did you just now do
No, I did this on purpose. This one was on purpose, yes. This one was on purpose. Yes, I did it on purpose. All right, so anyway.
Listen, we don't need to not do that again because that just is way more confusing than if you would have just done it right the first time.
But this is how you guys will experience it in
Now, if I'm
life.
on a test and you see me do it that way, it's because you did it that way, and therefore it's your fault.
Dude, but
You're
it's
not
your
gonna do it
responsibility
before, I'm
for
gonna
racing
do
on
that.
Do as I say, not as I do. Maybe, I don't know. Anyway, so
It works for a math teacher. You're teaching us right now. We have to do what you said.
okay, so What should we do at this point now?
Sometimes you are.
It's still no solutions.
Slide DK.
Yeah, I never like see it.
All right, let me take a step back here. Maybe something that's more familiar because we all just maybe don't like the trig. Okay, if we have a problem like this,
You
Divide by X.
okay,
You pull out
a common thing.
we divide both sides by x, right? That cancels. We're left with x equals 1, and we get a solution. X equals 1. Does x equal 1 make this equation true? Yes. Is that the only solution for this equation? Not -1.
Buddy.
That's funny. Someone else, my last block, said -1 too. I guess I could see it because the square, you think if 1 works, then -1 works. What other number works here? Besides 1, what else works? 0 works. Right. Okay. Whoa, wait a minute though. We solved this equation, and where did the 0 solution go? Right? 0 works. 0 squared is 0, 0. So what we should have done here is taking that x squared equals x, subtract the x over, and then what do we do from here? Well, there's a GCF of x. Factor the x out. And so using the zero product property, x equals 0, x minus 1 equals 0, so x equals 1. There are your two solutions. So yes, what are we going to factor out here? They both have a cosine in common, so factor a cosine out.
That's some wild stuff.
Mind blown. Well,
Should have factor out
this is what you need to know how to do, okay?
What did you say?
So, factor a cosine out, all right? So at this point now, we can use the zero product property. We have two things that multiply to give us 0. Cosine of theta equals 0. Sine squared theta minus 2 equals 0. Now, what do we know about this branch right here? What does it lead to? No solutions, right? That's what we just did. So we don't have to like redo it there. We'll just say no solutions, ... no solutions there. When does cosine of theta equal 0?
Oh. It's either 0 or 1.
Pi over 2.
Never mind. It's not 0.
3 pi over 2. It's at those places, but that's where it's pi over 2, 3 pi over 2, yeah, in this case. Okay? And oh my gosh, we see two solutions, and oh my gosh, there's 2 points of intersection. So second trace, intersect. Actually, you know what, I'll just do this. Second trace, I'll do value. So pi over 2, and look where that ends up, right there at that point of intersection, right? Second trace value, 3 pi over 2, and what do you know? There's the other point of intersection there, okay? So please be careful. Why did we run into this issue here? Why does this division that we did cause us these problems? Well, when you divide both sides by cosine of theta, you're making an assumption. Because what's the number we cannot divide by in mathematics, right? 0. Can cosine of theta equal 0? It can. So by dividing both sides by cosine of theta, you're assuming cosine of theta will not be 0. But it could be. And so that is what results in these kind of weird results. Okay? Questions anymore on that? Okay, so factor, set each factor equal to 0. So that being said, I got one more here for you all to try, and then I have one other thing I want to say too. So you guys try this one. Secant squared theta
Oh god, no.
tangent squared theta minus secant squared theta equals 0. So again, solve.
And I feel like this one is definitely one of those functions where it's just something. Oh wait.
Can you factor out a square?
You
No, it's a
could
tangent. That's one of them.
you could use an identity here, but it's not necessary. Sorry, say again.
Oh, you can't like factor out a secant because that's square.
Why can't you?
Yes,
Wait,
you
never mind.
can.
It's just tangent squared theta equals 0 because you can just subtract the secant square from secant square, couldn't you?
Try, write down what you're going to say, and I'll come around in and help.
Wait,
Okay.
If you pull out the square, just pull the square out of the tangent too.
Say it one more time. Sorry.
So when you're pulling out the secant square, does that pull a square out of the tangent?
Yeah. So the factor that you're going to pull out is secant squared. The tangent square will remain untouched
Okay.
because it's unto itself kind of thing.
Can you tell me if I have a set of corrected?
Okay. I'm coming around.
Wait, this is very difficult.
So factor out a secant squared.
Oh, we can do a triple.
What would you do? What would you do if theta left in the first secant. It's like it's multiplied by tangent. So
Wait,
you
but
just
when
write
you
theta
multiply
tangent
let's
squared
talk about
theta.
this.
You're left over with tangent squared, and then when you factor secant squared out of secant squared, you're left with just a 1, so it's minus 1.
Wait, but
Oh, then what do you do with the first secant squared then?
Yes, remember you take the square root of both, the square root of that is plus or minus that.
what's
Do you
this
have,
just?
the tan of theta?
You can square both sides, it's still positive, it's still 0, yeah, because there's no plus or minus.
Do you have any warm-ups theta? I haven't taken the root yet.
Wait, those two.
Yes. Did I not come and get your warm? I forgot to come get your warm-ups, didn't I? All right, Lindsay's gonna come around and get your warm-ups real quick. I'm sorry.
So,
No, sir.
so
Sorry,
Trip wire.
Sorry about that.
what do you do with the first secant squared then? It's you just write 1 times tangent, which is 1.
So it should be secant squared theta.
Oh, okay.
Right. Okay, and so you said each factor equal to 0.
What did you get for a pizza, Jim? You got,
Technically, when we're doing this, that's.
you got a little trip wire.
So it'll be secant squared tangent squared.
Oh, yeah. So then
You get put a theta there, put a theta there.
No, because secant is.
but technically, so like,
Go ahead,
is that right so far?
By half.
Is it right before? Yeah, yeah, now setting factor equal to 0.
Square root of 0?
Yes, what's the square root of 0?
0.
0. Hey.
By day.
Yes, well done. Good.
The tan is by day.
What's that?
Oh, wait, but
Oh,
there's
yes.
negative 2, so it's also, it's all,
I'll do that right now if I have it.
so it's also 3 by 4.
I just forgot until you asked me. It's like,
All right, it's fixed. You're welcome. Shh. Okay.
That's really weird.
So I think after all the discussions, you probably heard, you knew you should factor out a secant squared theta here, which would leave you then with tangent squared theta minus 1. Okay? Please be careful, folks, that you're factoring out secant squared theta. Don't just drop the theta, okay? That's part of the function. Okay? Now that we've factored out secant squared theta, that we have this product of, I don't know, we product of two terms here, we can do zero product property, right? So secant squared theta equals 0. Tangent squared theta minus 1 equals 0. Okay? What should we do to both sides here for this factor? Square root. And so square root of 0 is just 0. We don't have to worry about a plus or minus there because just square root of 0 is 0. We'll add the 1 over here. And then square root both sides. So we end up here with tangent of theta. Now, since we're in an equation setting, that 1 needs to be plus or minus 1 there. Okay? And so now we have to evaluate these trig equations. Secant of theta equals 0. When does secant of theta equal 0? Never. Never. Okay? Because if you're unsure about that, think about the reciprocal here. Reciprocal of secant is cosine. Reciprocal of 0, you can think undefined or 1 over 0 if you like there. Okay? When is cosine undefined? Never, right? You can plug anything into cosine and you'll never get undefined. Okay? So this is just impossible. It's a dead end there. Okay, no solutions there. But is tangent of theta equal to plus or minus 1? Is that a dead end?
no, there's 4 answers.
Right, there are 4 solutions. Okay, and what are they?
5
Pi fourths,
fourths.
5 pi fourths.
5 pi fourths,
3 pi 4.
3 pi fourths. I'm going to put them in numeric order. So yeah, 3 pi fourths, 5 pi fourths, and 7 pi fourths. That's all the pi fourths in the quadrants there.
Wait, they equal plus or minus 1.
Say again.
They equal plus or minus 1.
Tangent of any of these will give you plus or minus 1. So they give you all of them there. Okay, that's all of our answers. Okay? Shh. Questions on any of that? All right, so I got one more thing I want to just add on to these. So if you go back then to like one of the first problems we did here, let's maybe go back to our second example here. Okay? let's say instead of solving for 0 less than or equal to x less than 2 pi, let's say we were solving for all x. It'd be an infinite number of solutions. Right, exactly. We're going to put that thing on the end. So, what do I mean by that thing on the end? This is what we were talking about in the past. We were trying to describe all those like asymptotes and things. How often does sine repeat itself? Every what? 2 pi, right? 2 pi. And so, if we take 5 pi over 4 and we add multiples of 2 pi, or as I'm going to call that, 2k pi, and the same thing with 7 pi over 4, if we add 2k pi to that, that will give us our additional solutions. Now, we need to be a little bit more careful here. I'm going to specify that k is an element of the integers. Okay? This little e right here, that's the Greek letter epsilon, I believe. I think it's a lowercase epsilon for element. You know, it's short for element. Okay? And we'll do the same thing here. K is an element of the integers. If you don't want to write this in symbols, you can just write k is an integer. Like that too, okay? If you don't want to use the symbols. Your choice.
The first one is so much cooler.
Sorry, question?
Why do we get rid of the 5/4 and 3/4? Or is this a different one?
Because it was the second one that we did. It was because sine of x was equal to negative root 2 over 2. So we just did that. Okay? So that covers then all of our solutions. If you add 2 pi to that, or you subtract 2 pi. If you add 2 pi to 7 pi over 4, or subtract 2 pi to 7 pi over 4, you get all the possible solutions. Integer multiples of the 2 pi. Okay? Questions on that? I want to look at one more, and then we'll cut you loose on the homework, okay?
We're making good time with that.
We are making good time.
You're making great time.
It's always a good time because it's pre-calculus class, so I don't know what you're talking about. But, okay?
27 minutes right now.
Are you still using my charger that
All right, let's look at one more here, and that's this one, the one we just did. Okay? So, these solutions we got from tangent. How often does tangent repeat? Every pi, right? The period for tangent, right, is from negative pi over 2 to pi over 2. That length is pi. So tangent repeats every pi, which means for pi over 4, we should add k pi, right, or pi k, however you want to put it there. I'm going to put k pi. And again, k element of the integers. Okay, and then same thing with 3 pi over 4 plus k pi, k element of the integers. 5 pi over 4 plus k pi, k element of the integers. And then 7 pi over 4 plus k pi, k is an element of the integers.
Why do you need the last two? Isn't it just repeating?
Ah, right. So I'm actually being a little redundant here with my solutions.
You can do
The
the
first one.
So, right. The most efficient way we could do this is to actually, start with this first one, pi over 4, and add what?
2 pi over 4. Hey, 2
Or
pi over 4.
pi over 2. Yep.
2 pi over 4.
Or, let me tell you how wrong you are.
Why do we have
No, just
2
simplify,
pi
that's
over
all.
4 does mean pi over 2. Wait, isn't it every pi? 2 pi over 4. Yeah, it changes every pi.
Say again?
It changes every pi. I was still, it repeats every pi.
Each one of those original solutions, if you add pi to them, it will be repeated. But these can all be combined together in a single statement right here, because these are all different from one another by pi over 2. And so you can then say all the solutions in a single statement. Do you have to do that? No, but it is possible, okay? Do understand that it's possible. It covers all of our bases, does it not, right? So, okay? Questions on any of that? So, please abide by the directions in the homework tonight, because it will say sometimes just give all solutions, sometimes exclude, only keep it between 0 and 2 pi. So abide by those directions. If it doesn't specify, assume all. Okay, assume give all solutions. Okay? And then in the meantime, please take the time I give you now to get started on your homework. Yeah, I'm sorry, Lindsay. I'll be that 1 sec. Let me just get my homework up for them. Where did I put that paper? Okay, so your homework is page
See that one, yeah. Okay, you have the book.
394, numbers 11 to 19, 25 and 27, and these are odds. Yes. Okay, 11 to 19, 25, 27 odds on page 394.
Do it.